Hello everyone. Today we'll be solving this problem set matrix zeros. So this problem basically is asking us to so we're given a matrix and inside that matrix there's a couple of one zeros and other digits. So if there is a zero in any row or in any column, we have to set that entire row or column as zero. So as you see here, this zero so means this column and this row will get set as zero, and same for this. So when we start coding this, the problem that we see is while I am setting this like the row for this zero, I set this entire row. I don't want to consider this zero as an original zero and then start setting this row also as zero. So that is a problem. So we have to only care about the initial zeros, right? So that is one thing. Now, if when I want to care about the initial zeros, one approach we can think of is that let's save the rows and the columns that will get marked as zero somewhere. Let's say a set. So here this is row 1 and column 1, so let's have a set for rows, put 1 in it. Let's have a set for columns, put 1 in it. And later on I can iterate over this entire matrix. If this particular cell's row or column belongs to the set of rows or set of columns that we set initially, then we can mark that particular cell as 0. However, the space complexity for this would be O of n, O of n, yes, O of n plus m. Yes, O of n plus m, because we'll have one set for rows, one set for columns. Now, so this is a fairly simple approach, apart from the fact that we're wasting some space. So what if we want to do it in constant space? We don't want to give extra space. So what I was thinking of is basically what we can do is whenever you find a zero in any row or column, you set that column's first element as negative and row's first element as negative. And later on, while iterating, you can again check the columns first uh, matrix if that is negative or not. But the problem is when I set this row as 0, when I'm at 5, I check here. So this is actually 0. I can't set this. I can set this as negative, and this is not even the original 0. So that is again a problem. Correct. Mm, so yeah, we just need to figure out the storage solution. Mm, and even in storage, the negative approach was fine up until if the element that I want to set as 0 is so set as negative is 0 itself. So how do I set a 0 to negative? Good, good. Okay, that is a problem. Like for 5, when I check the first cell of this column, I see 0. It's not negative. What do I do now? Hmm. Okay, I can probably do one thing. I can. So my numbers, they range from int min to int max. Okay, that is another problem. I can't even set some random unique value. And another problem would be when I'm over like when I'm setting these to 0, the negative value that I set initially will get deleted. Mhm. Okay, so what can we do here? Just a simple matrix of zeros and ones, zeros and other digits. How can I uniquely identify? It can have negatives also, right? Matrix size can be negative also. It is a matrix of integers, so we can't cross that barrier as well. Can't use negatives because the matrix can contain negatives. So we have a 0 in a row. I want to set all other, but I also want to identify that 0 uniquely. The whole integer range is not going to help me. Saving the rows and columns is the only way I see Bad idea. A single improvement. M plus n space. This we have already discussed. We'll have two sets. Now we are thinking about this constant space solution. Okay. So let's take the second example. I have a 0. I want to go and set the entire row as 0. I find another 0 there. The problem is it's primitive integer type. If it was integer object, I could have made it null or something. Yeah, basically, how do you differentiate between a 0 that was originally there and a 0 that you have put? Or a 0 which is like coming from somewhere else. This is tricky. What can we do here? For constant space. If we just want to go over this. Okay. So we have this array here. We find the 0. Now we want to know. Okay, this is probably a bad example. I needed a. This is very symmetric, but anyway. So we have the 0. Now this 0 would mean this entire column, this entire row is going to set as 0. Now, like I said, initially we could have a negative here. We can't have a negative, we discovered, because negativity. But let's say I set this one as 0. Okay. Now setting this one like the head of the column or head of the row, I will set this as 0. And later on use these, the heads, to set others, the inside ones as 0. Okay. and so these would cause the problem that if this one is 0, what if it gets mistaken as original 0 and it colors this entire row, or sorry, this column or this row. So for this we could have an initial checking if this is going to be filled or not, right? So okay, yeah, I think we can do it this way. If there is any 0 in this row, we'll check that first of all, and if there's any 0 in this row, we'll check in this column, sorry, we'll check that also first of all and save that. Later on, we'll fill the heads for whichever cell we want to fill. Based on these cells, we're going to fill the matrix, and at last I will check if I need to. If my initial flag was true, then I will color this entire row, and same for this column. All right, boolean, let's call it r0. I'm going to call it, so that is row 0 equals to false. Okay, and this would be column 0. So for int I equals to 0, I less, okay, I need n and m. Come on, int n equals to matrix dot length and int m equals to matrix 0 dot length. All right, so I is basically for n and I plus plus. So basically if my matrix, okay, this is going matrix, let's call it mat actually. Okay, matrix of, so I is increasing, but I just want to know the first value. If this is 0, then the column 0 equals to true. And same thing I'm going to do for, come on, so for j0, j less than m, and can do j plus plus, and then for if 0 of j is 0, then means r0 has to be colored. Now let's traverse inside. So basically I0, let's go inside. Let's not iterate over the first row or first column. So this is j less than m and okay, j plus plus. So now we are inside. So if matrix of I and j are 0, then I need to set matrix of, okay, matrix of I. So if anyone is 0, I0. Okay, so I0 equals to 0 and matrix of 0j equals to 0. So basically we have colored the heads of the rows and columns. Okay, now what we'll do is, so I have an identifier if a particular cell has to be colored or not. Now again I will go inside and now I will check this thing. Okay, so I'm saying if matrix I0 equals to 0 or matrix 0j equals to 0, then set my matrix ij as 0. Alright, now let's do this. Now the color, to color the initial, come on, what is happening? If, so this is for column 0. If my column 0 was colored initially, then I will traverse through I0 and I will set my matrix I0 as 0, and if R0 was set, then I will traverse through the first row and set it as 0, and then I can return my matrix. I hope this works. Okay. Mm, clear condition. You can auto return. Perfect. Wonderful. So I'll just explain once again how this worked. Um, okay, so take this example and imagine this 4 was 0 instead of all other zeros. Only this one is 0. So for this one, I want to mark one as that's the whole idea. We want to mark an entire column or entire row somehow. Negatives can't work because my matrix elements can also be negative. 0, and then you only have the integer range, so you don't have anything unique left. So for when you find this 4, this is 0. I'll put my mouse over it so you know that's 0. So when this is 0, we want to mark this 1 as 0 and 3 as 0. Correct. I will do this, and then what I can do simply do is, uh, for any cell in the full array, if that cell's head row is 0 or head column is 0, I can mark that cell as 0. Simple enough. Now the problem is, when you do this, you have marked this guy as 0. So when you come here, so you have marked this guy as 0. So problem is, you might start marking this entire row as 0 because this one is 0. You might think this was initial 0. That is a problem. We can't do that. So to tackle that, what we did is, in the first run, we identified if there is a 0 in this row. Now we know that if this 0th row will be colored as it filled with zeros or not. We did the same for this. And now later on the operation that is there, checking the heads and filling the array, we won't do it on these because these are like our markers or whatever now. We will only do it here. And finally, we again check if this was supposed to be 0, I'll make it 0. If this was supposed to be 0, I'll make it 0. All right, cool. Thanks for signing in. See you in the next one. Bye bye.